So we're continuing our discussion on simplifying expressions, and we've already talked about the first of those two forms of simplifying is the distributive property. That's going to be a key concept that we use a lot throughout this year, particularly when it comes to solving equations. We'll need to simplify by distributing, but we'll also need to recognize when there's opportunities for us to simplify by combining like terms, because that is the second primary way in which we need to know how to simplify expressions. So since we're talking about combining like terms here, we want to make sure we understand what a term is. We need to make sure we understand what a term is. So a term, as you can see defined here, is any number on its own. So numbers like 6, -18, 2/3, and what I really mean by that is any real number, okay? It can also be a variable on its own, like the variable x or the variable a or the variable m. Now this is where we really need to be careful because numbers and variables are the smaller building blocks that ultimately can be put together using multiplication. So the important thing here is that terms can be put together with these two pieces, but only as the product of those pieces. So it can be the product of a number and a variable. Okay, let's see. So 4a is a term. Actually, I want to be careful here because as I'm looking at this, I'm seeing I don't like what's in these notes. As a product of a number and a variable, I should say not separated by addition or subtraction. That's a key omission on my part. So I want to make sure that we understand. So a term is the product of a number and or variable. So 4a, that's 4 times a. 4m squared times n, we could think of as a product of 4 times m times m times n. That would be the product of numbers and variables. So that's perfectly fine. The terms here, this is not all collectively a term. This is called an expression. And the reason why it's called an expression is because we now have terms joined by addition or subtraction. So again, a key word for us to make sure we add in here is that it's a product of numbers and variables not separated by addition or subtraction. So when I look to identify the terms in this expression, so 8 is a term, 3m is a term, okay? Whereas in the next expression, ignoring the operations, in the other expression, x is a term. If I thought about keep change opposite, I could think of this as x plus negative y plus y squared. So if I view it that way, then negative y is another term, and then y squared is my final term. So that's really important for us to know that the terms are the individual building blocks that make up an expression, and those building blocks are made up of smaller pieces known as terms that are numbers and variables. Okay? So if we're going to move on to determining what like terms are, well, I'm going to just explain to you that like terms share the same variable, and equally as important, those variables are raised to the same power. So if I go back up to this last example, you notice these two terms both have y. That seems to begin to fit the criteria for what a like term is, but they aren't to the same power. The negative y is y to the first, and when we compare that to y to the second, they are not the same variable to the same power. So those are not, I repeat, those are not like terms. So let's look at an expression made up of a series of terms, and let's just group them as like terms, and we'll go alphabetically. So I notice I've got terms with x squared, terms with y, terms with x, again, terms with y, and then I have some numbers on their own. Those are what we call constants, okay? So the 9 and the -11 I'll just kind of draw, those are examples of constants. Okay, they don't have any variable attached to them. So they're just numbers. As I said, they are terms called constants, but they are still terms. And they'll be like terms because they're numbers, no variables attached, that makes them alike. Okay, so let's take a look. Alphabetically, I'm actually going to go highest power to lowest. So my first group I'm going to look at are those terms that have an x to the second power. So my first group is going to be made up of 4x squared. And we're just going to separate with a comma. 3x squared and 2x squared. So that's one group of like terms. I have another group of like terms that have x, but no to the second power. So a second group of like terms will be this positive 6x. Now this, again, I want to think of as like plus negative 1x. So I'm going to say negative x. And we'll talk more about that and make sure we have clear understanding of that when we discuss combining like terms in class further. Okay, so that's another group of like terms. Let's see. And then I can move on. I'm all done with all my terms alphabetically with x, meaning those terms with x squared and with x on their own. I'm going to move on to those with y. So now I have a term that's 4y. And if I was going to call negative x minus x negative x as a term, I'm going to think of minus y as negative y as a term. So that takes care of these terms here. And then my final terms are my numbers on their own. Okay, so I have this 9 and I have that negative 11. Those are my constants. So what I can begin to do, since I've already taken the liberty to group these together and accounting for their signs, I can combine now. I can combine. And combining is just addition, okay? So just add. Add all my terms in blue together. So let's see, I have 4 of these things known as x squared, plus another 3. 4 plus 3 is 7, plus another 2. That would be 9x squared. I have, in the next group, I have 6 of these x's, but I took 1 away. Think about 6 minus 1. I now have 5x. In the next group of terms with the y's, I have 4, and I took 1 away, right? Or I add negative 1. That means I have 3y. And then I have 9, but I'm adding to it, I'm combining to it negative 11. That's like saying 9 plus negative 11, which gives me negative 2. So the last step, and we could do all this together, and you'll see in the final example, we'll just kind of mix all this together. But I want you to see an expression, be able to kind of separate out, deconstruct, and lump all the like terms together. I wanted you to get used to seeing what the sum of those like terms were in their individual groups. And now we can just write a final expression. The final expression would be the 9x squared, and since combining is adding, plus positive 5x plus combined with positive 3y. And here, instead of saying plus, well, if I say plus negative 2y, I'm sorry, plus negative 2, I want to clean that up. So instead of saying plus negative 2, I just want us to get used to saying simply that it's minus 2. And that's done. That's it. We're done. So the original expression that you saw up above, by the time we're all done, it simplifies to this expression. And this should be equivalent. This should be equivalent to the expression that we started with up above. So if I gave you a value of x and I gave you a value of y to substitute in, you would get the same outcome following order of operations, whether you did it to the lower expression, more simplified, or to the original expression that was not simplified. Okay? So let's do one more. So we have one more expression. This is where we're going to get a little more efficient with it. Okay? So here's an expression, 4x squared minus 5x minus 9x squared plus 7x plus 8. I want to look alphabetically. I notice I've got X's everywhere, but I like to start by going with the higher power first. So what I like to do is use this box method. I'm going to put a box around the 4x squared. I'm going to very deliberately put a box around the negative 9x squared. And I'm going to combine those together. 4 and negative 9, 4 minus 9, that's going to give me negative 5x squared. I'll then move on very deliberately. Maybe this time I choose circles. I'm going to circle the terms with x to the first. I have negative 5 of them to be combined with positive 7. Well, negative 5 plus 7 gives me plus 2x. And then I move on to my constants because I've run out of variables. And in this case, there's nothing to combine. So I just finish up and I say plus 8. So this, when we get to class and do more practice, is actually the method I'm going to be encouraging. We use this box and circle method, and we go on down the line. There's kind of a hierarchy. We go alphabetically, but we also go, if the variable is the same, by higher power down. So once again, I need to stress that this expression is equivalent to the expression that we started with. So regardless of which expression I choose to substitute in for x, when I follow order of operations, I will get the same outcome. So that is our lesson on combining like terms. I'll ask you to complete the Google form to go along with it to confirm your understanding, and we'll do more practice in class. See you then.